So this is problem 511 for standard 5.3. The problem says a particle is in the ground state of an infinite square well. The potential well at x equals 3 suddenly moves to x equals 3, so the well is suddenly 3 times its original size. So it wants the probabilities that the particle will be in the ground state or the first excited energy state. And so the equation to find the probability that it's in a certain energy state is modulus squared bra en ket psi. And this can be rewritten as this. The integral from infinity to infinity of psi x phi x dx squared. And this function is defined as the square root of 2 over L sine n pi x over L, and that's basically the allowed eigenstates. And this n is any positive integer, so 1, 2, 3, 4, 5, etc. And so the probability of being in the ground state is going to be modulus squared the integral from 0 to L times the integral from 0 to L with square root of 2 over L sine squared pi over xl, and then times square root of 2 over 3L sine pi over x over 3L. And this is 3L because we know the length is now 3 times the size, and this n becomes 1 because we're finding the ground state, so the first n is 1. And then so you're going to solve this integral and then square it, and you're going to get 9 over 8 pi squared. And you do the same thing for the next energy level, except now instead of using n equals 1, you use n equals 2. So it's going to be the modulus squared integral 0 to L square root of 2 over L sine 2 pi x over L. And see, this time the n is 2, and the length for the second part is also 3L still though. And again, we changed the n to 2. Solve the integral from 0 to L, and it's 9 over 5 pi, and then that's squared. And those are our probabilities.